Okay. This sheet still, Mia? Sure. Okay. So I notice one thing here right away if I take a look at this. If I look at the coefficients, 4, 8, and 20, all have a greatest common factor there. So I'm going to start by doing that to make my life a little bit easier. Good with that? Then I'll look for the two numbers that multiply to give me 5 and add to give me -2. There's no two such numbers, so that's as good as I can do. Yep, that's as far as you can go. Yep. That's our answer. So this is good. The ones you guys have been asking about are basically the ones that don't work, which tells me that you're doing pretty good on the ones that do work, right? Sure. Okay. So we just need the two things that multiply to give us positive 24 and add to give us -8. So I think, again, this is no two such things are going to work. Let's just run through our choices here real quick. Holler at me if we see anything that works. And that's it, right? So nothing. This is just not factorable. You guys did a good job of identifying all the not factorable things. I think that's all the questions we've asked today are about the ones that don't work, which is good, right? Tells me that the ones that work we're probably figuring out and getting right, which is awesome. Maddie. Sure. Okay. So multiply to give negative and add to give 0, right? So that we need 2 and -2. We make our two groups, 2x, and take out a -1.
So the two parentheses should give you the same.
Right here? Yes. Yes. Ah. Yeah. So if they're not the same, either you've chosen the wrong two numbers, which is usually the likely culprit, or you've made a factoring mistake. That happens also. Okay?
Thank you.
Of course. Okay. Anybody else on sheet 2? Should we move on to sheet 4? Okie dokie, artichokes. Oops, that's not the bottom or the top. Okay. From sheet 4, what do you guys want to look at? Any questions here? Mia? Number 4? Oh yeah, I misnumbered them here, huh? Ah. So this one. Okay. So we'll FOIL this out, and maybe it's one that I just made a mistake on. You know, that's entirely possible. So let's see. Looks like it. Right? Yeah. So that's just not factorable. This is an oopsie. Oh, sorry. No, it's not. 36 minus 9 is not -37. It's -27. Goodness gracious. My goodness. I am not on my game day. So, multiplies to give me -27, adds to give me 6. That's about 9 and -3. and then everything is fine. That makes me feel better. It's like I tried hard on this not to screw that up. I was going to be frustrated with myself if I did. But I just screwed up arithmetic, which is just as embarrassing as screwing up the problem that you try to do in your head, that you're like, I'm going to be very careful and make sure I don't screw this up. So it's like equal parts embarrassing there, I guess. But at least they didn't make a mistake when I tried hard to not make a mistake. Here, when I was just trying to go, and I went, oh no, and then I started second-guessing myself. Okay. Any last takers on homework 4 here? Happy to do more if you have more to ask about. If you don't, though, that's fine. No big deal. Okay. Sunday are these 2 assignments. So these are on the homework check on Sunday. I think I already have that up on PowerSchool. Okay. You've confirmed that I do have it there? Okay. Thank you. I appreciate that. Today, we're going to talk about factoring shortcuts. So you've seen the full factoring method, the long factoring method that involves that factor by grouping technique. Today, what we're going to do is we're going to talk about situations in which we can avoid having to do that factor by grouping. So in each of these situations, I'm just talking about a standard form polynomial, something written in the form ax squared plus bx plus c. And really, like, I guess it goes without saying, if it's quadratic, the a can't be 0, right? If a is 0, then there's no x squared, and it's not quadratic anymore, right? So the first situation is if c is 0. So if c equals 0, it just means that all you can do is a greatest common factor. So for example, let's say we have 7x squared plus 5x. All I can do is take out an x. That's it. No factor by grouping needed. Pretty easy, right? Second situation, if I have something in the form d squared x squared minus e squared. Greatest common factor. No, that's okay. I said it when I wrote it, but I didn't. I figured that was a common abbreviation at this point, but no problem repeating. So the second case here is if we have something in the form dx squared, or d squared x squared minus e squared. We call that the difference of 2 squares. I abbreviate that as DOTS, difference of 2 squares. That's a common math term. I abbreviate that just dots because, well, it comes up a lot. And below what I've done is I've written the factoring pattern for it. So we can just write that factors as dx minus e times dx plus e. So for example, 4x squared minus 9 is something where I could use that shortcut on here, because I notice that this is equal to 2 squared x squared minus 3 squared, right? Everybody see that? So this factors just into 2x minus 3. That kicks butt, right? Worth noting, we have to be a little bit careful here. Can I do the same thing here? This is not factorable. Why not? There's only one difference. Yeah, has to be a difference of 2 squares. Right? Has to be something squared minus something else squared. If it's plus, no dice. We okay there, though? Fairly easy to deal with, right? The third situation is if the leading coefficient is equal to 1. In that case, we have two numbers that multiply to give us a times c and add to give us b. Let's just, for the sake of argument, call those letters or those numbers m and n. Then ax squared plus bx plus c is equal to x plus m times x plus n. This is the most versatile one. So let's say we have x squared plus 7x plus 12. We're eligible to use the shortcut on this one because notice the leading coefficient is 1, right? We have 1x squared. So all we need to do is find the two numbers that multiply to give us 12 and add to give us 7. Those two numbers are, anybody? 3 and 4, thank you. So that tells me then my answer is x plus 3 times x plus 4. Done. No grouping necessary. Let's do another one like that. That's pretty righteous, right? That's a pretty good shortcut, as it works a lot. And it's the only shortcut we have that works for a trinomial, right? All the other shortcuts require binomials so far. How about this one? How does this factor? Let's just not write anything down. Let's just write down the answer. Okay, so those are the two numbers. So I'll write x minus 7 and x plus 2. Done. We okay there? Quick show of hands, those of you that, did you do this kind of factoring in your Algebra 1 class or remember doing this type of factoring before? Yeah, you might have done it right at the very end of your Algebra 1 class for just a little bit. Some people did a lot, some people did a little, some people didn't do this at all. That's okay. We're presenting this as nobody's seen it before. If you have, that's great. You're at a little bit of an advantage. If you haven't, no big deal. My expectation is not that you've seen this before. I just was curious. Okay. Everybody feel okay with these three shortcuts? Cool. What we're going to do now is some practices. And we're going to eventually, well, hold on, let me back up the truck here just a little bit. We're going to do some practices. This skill right here, the skill of factoring, quadratics, may be the most important first semester skill we encounter. You're going to encounter quadratics all the time from here on out. Even when you least expect them, they're going to crop up and you're going to be like, oh, this thing again. And being able to factor them is a very, very important skill. In particular, we need to be able to do these shortcuts quickly and accurately, because these are the things that kind of pass this course we're going to expect that you can do in your head, and we don't have to write anything down, and we don't have to explain anything more. It's just one of those things that's like, yep, and I have this, turns into this, and keep on going, and nobody blinks an eye at this. But for that to happen, we have to get good at it. We have to practice it. So the rest of today, we're going to do some timed factoring practices. So we're going to start with situations where they can all be done with shortcuts that should be able to be done pretty quickly. And we'll transition to situations that are maybe a little bit more complicated, that maybe can't all be done with shortcuts, but some of them can be. And just kind of work through some examples. Okay? So we're going to do a bunch of practice today just on this skill. We're going to do it timed together in class, the idea being that you have nothing new to take home for you this weekend. Sound good? I thought you would like the second part of that. Okay. So I'm going to stop the recording now because, well, it doesn't